Hello and welcome to the second tutorial on Arduino. It is about the Arduino Uno Revision 3 board which we will be using in this tutorial series. This is Rushikesh from Project Labs and let's get started with the Uno. We will take a look at Uno and all the stuff on it. We'll then see the use of different pins, some technical specifications along with the absolute maximum ratings. People often skip this part and jump directly to programming. But if you really want to master the Uno or any other hardware, you must know all these things about that particular hardware. So let's master the Uno. Here is the Arduino Uno with Atmega 328P microcontroller at its heart. A 16 MHz timing crystal provides its heartbeats. You can power up the Uno by a DC adapter or through a USB port, which can also be used for programming and debugging. Microcontroller on Uno and PC talks with each other through a USB port via Atmega 16 and their communication can be seen on TX and RX LEDs. One more way to program the Uno is through in-circuit serial programming. A reset button on the top left-hand corner will reboot the Uno. A debug LED on pin number 13 to test the programs quickly without constructing any external circuit. And along the sides are the set of input and output pins. Now let's see whether we can find all these things on the circuit diagram. The Atmega 328P microcontroller chip, a 16 MHz timing crystal. You can connect a DC power adapter here, which will lit this green LED. The USB port for powering, programming and debugging via Atmega 16 chip. TX and RX indicator LEDs. An alternative arrangement for programming using in-circuit serial programming. A reset button for reboot. A debug LED connected on pin number 13 and set of input and output pins. Now, after looking at all the stuff on the Arduino Uno, let's see its various pins in detail. We can divide these pins in different sets as digital input-output pins, analog input pins, power pins, and some miscellaneous pins. Now, let's see these pins one by one, starting with digital input-output pins. Each of these pins can be programmed as either input or output pins, and they are digital in the sense that they can read the voltage levels 5 volt or 0 volt when programmed as input pins and can apply 5 or 0 volt when programmed as output pins. Now, few of these pins are special and called as pulse width modulation PWM pins, indicated by wavy lines next to the pin numbers. They can adjust the voltage they can apply between 5 and 0 volt. It means they act like analog outputs. Pins 0 and 1 can also be used for serial communication with the other serial communication hardware. Now, if you remember, we have seen that PC and Atmega 328P microcontroller communicates through USB port via Atmega 16 uses the same TX and RX pins. Let's see it once again. Here is Atmega 328P microcontroller chip connected to the USB port via Atmega 16 using TX and RX pins. And the same pins can be used to communicate with the external serial hardware. So if you want to do a lot of serial communication with Arduino on a certain project, probably better off not to use these TX and RX pins much because it might affect how your program operates. Pins 2 and 3 can also be used for interrupts. An interrupt allows certain important tasks to be executed first by halting the normal program execution for a time being. Pins 10 to 13 can also be used for serial peripheral interface communication. Now moving on to the second set of pins, that is analog input pins. These pins can be connected to things like a temperature sensor, a microphone, or a variable resistor. Basically, anything which gives a range of outputs between 5 volt and 0 volt. These pins gives access to a thing called analog to digital converter ADC present on the microcontroller. The ADC takes an analog signal and converts it into a digital one. A pin called AREF is used to set the reference voltage of this ADC. Pins A4 and A5 are serial data and serial clock pins used in two-wire interface communication. The same pins are made available here separately. Power pins are used to connect 5 volt, 3.3 volt and ground to the external circuits. You can supply external voltage through VIN pin, or if you are supplying voltage via a power jack, You can access it through this pin. If you supply a logic 0 to reset pin, it will reset the microcontroller. It is typically used to add a reset button to the shields, which blocks the one on the board. IOREF pin provides the voltage reference 5 volt or 3.3 volt with which microcontroller operates. This pin is unused, but it is there to ensure compatibility with the future products. Whatever we have seen up to this point will be summed up in the technical spec sheet for Arduino Uno. Starting with Atmega 328P microcontroller operating at 5 volt, a DC power adapter or external voltage at V-in pin should be between 7 to 12 volt, a timing crystal of 16 MHz. It can be programmed through USB or using in-circuit serial programming. Some memory details. It has 10-bit ADC, means it converts an analog signal into digital signal of 10 bits. These are all serial communications options available with this board. It can accept 2 interrupts. It has 14 digital pins, out of which 6 can be used for PWM. It has 6 analog pins and provides a DC current of 20 mA per pin. And last but not the least are the absolute maximum ratings. Please jot it down somewhere, as these values will be useful while designing the external hardware to be connected to the Arduino. I look forward to seeing you in the next tutorial on Arduino IDE, where we will actually start working on Uno. Please give us a thumbs up and share if you like this video. Subscribe to our YouTube channel for more such videos. You can also visit our website projectlabs.in. Thank you very much for watching.